Okay, everyone, this is lesson 40 for the algebra class. We are doing simplifying and evaluating expressions using the power property of exponents. Okay, so go down to the new concepts here. Okay, previous lessons have explored expressions using exponents. Several rules and definitions have been developed. All right, so we know that x to the 0 power is equal to 1 as long as x is not 0. So 10 to the 0 power is 1. 8 to the 0 power 1. Okay. Anything to the 1 power is itself. Okay. 10 to the 1 power 10. 8 to the 1 power 8. We know that division, if it's a fraction, if they have the same variable or same base, you would subtract the exponents. Okay, subtract the exponents. We know that for multiplying and it has the same variable, we add exponents. Okay, and we also know that if a variable with a negative exponent, it really is a desire to go just like a top and a bottom. If it's at the top, like this one, even though you don't see the bottom, if it's at the top, it wants to go to the bottom because it wants to have a positive exponent. These are not negative numbers, they're negative exponents. Okay, well, there's another one. There's another property of exponents that involves raising a power to a power. Okay, so raising a power to a power means if you have, say for example, 2 to the 4th to the 3rd power, this means that you want 2 to the 4th 3 times. So you would have 2 to the 4th, okay, times 2 to the 4th times 2 to the 4th. There are 3 of these. That's what the 3 means, okay? Then, once you have 2 to the 4th times 2 to the 4th times 2 to the 4th, it goes back to this one. You have the same base. In this case, it's 2. So you would add all these exponents to get the answer. So 4 plus 4 plus 4, and you would get 2 to the 12th. Okay? So they have a couple examples here. See here. They have some examples. Okay, the first example they have is, okay, 3 squared to the 3rd. Okay, 3 squared to the 3rd means 3 squared times 3 squared times 3 squared. Okay, it means 3 squared times itself 3 times. And then you would add the exponents. Okay, now the good news is you get 3 to the 6th. And the good news about this is you don't have to write it out every time. You can just say, what you can do is apply the rule of, you can multiply these two exponents. So 3 times 2 is 6. All right, look at the next one they have. They have 4 to the 5th squared. Okay, 4 to the 5th squared. Now, again, we could write it out. We could say, well, that means 4 to the 5th times 4 to the 5th. And I know that since it has the same base, which is 4, we add exponents. So that would be 4 to the 10th. Or I could just apply the simple rule of, okay, I need to multiply those two exponents. The base stays the same. That gives me 2 times 5 is 10. Either way, you're going to get the same answer. Okay, so what do you think about this one? 7 squared to the 4th. I'll give you a second. You should have gotten 7 to the 8th. Okay, are there any patterns? What conclusions can you draw? Well, the conclusions that you can draw is the fact that, what are we going to do? We're going to multiply these exponents. So let's look at ones that they have without numbers. They have just the variable. So we have a to the 3rd to the 5th power. Okay, what is a to the 3rd to the 5th power? Hopefully everyone sees that it is a to the 15th. Sorry about that, but that is a 15, not a 16. Okay, or b to the 6th squared is b to the 12th. 6 times 2, 12. D to the 4th is d to the 16th. Okay, so hopefully that makes perfect sense for you. Okay, so look at the the power of a power property. If m and n are real numbers and x does not equal 0, then if you have x m to the n, you just multiply m times n. Okay, so simplify each expression here. Example 1, 2 to the third squared. 2, 3 times 2 there. The 2 exponents, 3 times 2, 2 to the 6. And if it's a variable, doesn't change anything. A, and that's what, 6 times 3? Or, excuse me, a to the 6 to the third power. You multiply 6 times 3, you get a to the 18th. Okay, so this can be used together. It says if you have a coefficient first, basically the third power, it applies to the 5 as well as the x squared. So you would have 5 to the third, okay, times x to the 6th, right? Because 2, 4, 6, x to the 6. So it's 5 to the third times x to the 6. That's why they get 125 x to the 6. Okay, let's do a few of these because bringing in a variable does make it a little bit more challenging. Not impossible, but you have to remember to use the apply the exponent to the coefficient as well. Okay, so we have 7a to the third, b fifth, and this is all to the third power. So each one of these goes to the third power. Okay, so you have 7 times 7 times 7, because that's 7 to the third. We can multiply the exponents. 3 times 3 is 9, b to the 15th, right? It's almost like you distribute the exponents to each one. Then 7 times 7 to the is 343, and this is a to the 9th, b to the 15th. Okay, same thing with a negative. If you have a negative coefficient, negative 2 to the y to the 4th to the 3rd, okay, that would be negative 2 to the 3rd power times y to the 12th power. Negative 2 to the 3rd power is negative 8, y to the 12th. Okay, how did I get negative 8? Well, negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. You got to remember that negative comes into play there. Okay? All right. Let's go to example 3 here. Example 3, a square room is being measured for carpeting. If the length of one side is 2x feet, what is the area of the room? Remember, area of the room, we basically do, if it's a square, then that would be one of these sides squared. That's why they have that written like this. So you have one of the sides is 2x. So it's just like a rectangle, length times width, which is 2x times 2x, which is 4x squared. Okay. All right. That was example 3. All right, let's take a look at example 4. Now, example 4 looks like they have they're bringing in fractions, which we love fractions. I know we love fractions. Take a look at the rule. If you have an exponent, it applies to the top and the bottom. So if there's parentheses there, okay, the parentheses mean it applies for the x and the y. So for example, for a, it is 2x to the 5th squared. That means that it's 2x to the 5th times 2x to the 5th. Okay, those parentheses there mean that it applies to both the top and the bottom. So you would just multiply it, 4x squared times 25. Okay. The next one, okay, so we have, for the next one, we have negative x squared, 3y to the 3rd, and this is to the 4th power. So what you can do is go ahead and multiply, but you got to remember it applies to the coefficient, which is, in this case, is -1. So -1 to the 4th power would be +1. Okay, -1 times -1 times -1 times -1 times -1. -1 times -1, +1. -1 times -1 is +1. Or we could just, okay, let's do it like this. 1 times -1 is -1, and then you still have 1 -1. Remember, negative times negative is a positive. Okay, so that gives you 1 x to the 8th over 3 to the 4th is, what's 3 to the 4th? 81. And then y to the 12th. Okay, there you go. All right. There's the answer. Same thing I got. Okay. Let's see again. Okay, so let's go to example 5 here. Simplifying expressions with powers. Simplifying, you're going to, if they line them up, you need to do the powers first. Okay, you go ahead and apply those exponents first. After that, you can multiply, but you have to do the powers first. If you do, you do the powers, you distribute those powers. Okay, so 4 to the 2nd is 16, x to the 2nd, y to the 4th. And then this one would be 2 to the 2nd is 4. 3 times 2 is 6. Y to the 2nd. And then you would multiply. Same thing goes with that one. Okay? All right, for this one, go ahead and do the lesson practice. It is on page 251, A through G. Okay? A through G. And also A through G, and also obviously at the end of the 3 lessons this week you'll have a review, and one of the reviews will be this lesson. Okay, good luck, and goodbye.